In this section, we will be multiplying polynomials, beginning with monomials. Now, in example 1, we have 3x to the 5th times negative 2x to the 9th. Now, for this problem, we will be applying the multiplication property of exponents. So, beginning with the numbers, multiplying the numbers with the numbers, 3 times negative 2 gives us negative 6x to the 5 plus 9, which gives us 6x to the 14th power. Example 2, we have a monomial multiplied by any length of polynomial. And to evaluate this, we want to apply the distributive property. We want to take the monomial, which is located on the outside of the parentheses, and distribute that into the parentheses. We want to multiply every term inside the parentheses by 5x cubed. So starting with 5x cubed times 2x to the 5th, 5 times 2 gives us 10. X cubed times x to the 5th gives us x to the 8th. Next, we have 5x cubed times negative 4x cubed. 5 times the negative 4 gives us negative 20. X to the 3 plus 3, or 6. 5x cubed times negative x gives us negative 5. X to the 3 plus 1, or 4. And last, 5x cubed times 8. 5 times 8 is 40, and we have the x cubed. For example 3, we are multiplying binomials together. And we want to do this really by the distributive property. We're going to extend the distributive property so that we can multiply binomials and larger polynomials together. In order to do this, if you look at this first example, we have x plus 3 times x plus 4. I want to take both terms in this first set of parentheses and distribute them into the second set of parentheses. So starting with this x, I'm going to distribute x to both terms in the second set of parentheses. So I'll have x times x gives me x squared. X times 4 is 4x. Now do the same thing with the 3. Distribute the 3 to both terms in the second set of parentheses. 3 times x is 3x. 3 times 4 is 12. Now if you look at this, we have some like terms here in the middle. We have 4x and 3x, and we do need to combine those. So we have x squared plus 4 plus 3 is 7, x plus 12. For part B, the example is very similar. We have m minus 5 times m minus 6, and we're going to distribute, starting with the m, to both terms in the second set of parentheses. M times m is m squared. M times negative 6 is negative 6m. Do the same with the negative 5. Negative 5 times m is negative 5m. Negative 5 times negative 6 plus 30. Combine like terms, we have m squared, negative 6m, negative 5m. Negative 6 minus 5 gives negative 11m plus 30. Next example, part C, same idea. We're going to multiply the first terms, so 2d times 3d. That's going to give us 2 times 3 is 6. D times d is d squared. 2d times 5. 2 times 5 is 10d. The same with the negative 4. Negative 4 times 3d is negative 12d. Negative 4 times 5, negative 20. Combine the like terms. We have 6d squared plus 10d minus 12d. 10 minus 12 is negative 2. D minus 20. Now part D, you have a binomial times a trinomial. So this idea of distributing all terms in the first polynomial into each term of the second polynomial will work no matter what the size, no matter how long the polynomial is. So here we're going to do the exact same thing we've done before. Start with, in this case, the x, and multiply it through to every single term of the second polynomial. So we have x times x squared, that gives us x cubed, x times 2x, so plus 2x squared, x times a negative 4 will give us minus 4x. Do the same thing with the negative 2. Negative 2 times x squared is negative 2x squared. Negative 2 times 2x is negative 4x. Negative 2 times a negative 4 is a positive 8. Now we need to find the like terms. So starting with the x cubed, then moving on to the x squared. There's 2x squared, negative 2x squared. 2 minus 2 is 0, so plus 0x squared. Now for the x's, we have negative 4x and negative 4x. That gives us negative 8x. And then we have our plus 8. Now this term right here, 0 times any number will give you 0. So the last step is to write this expression without the x squared term, so x cubed minus 8x plus 8 is our final answer. Now example 4, we are squaring binomials, and this is an extension of what we did in example 3. It just looks a little bit different. You have a problem like in part A, n plus 5 squared. Now if you notice, our multiplication property of exponent does not apply here because you are adding the terms inside the parentheses. You cannot do the power of a product rule here because this is not a product, it is a sum. So in order to evaluate this, you have to expand it. You have to write it out as a product. So n plus 5 squared can be rewritten as n plus 5 times n plus 5. Now multiply it out as we did before. N times n gives us n squared. N times 5 gives us 5n. Do the same with the 5. 5 times n is 5n. 5 times 5 is 25. Combine like terms. We have n squared plus 5 plus 5 is 10n plus 25. Part B, very similar. Again, we are subtracting, so we can't apply the power of a product rule. We have to write this as a product. We have to first expand it. So 3 minus 2a times 3 minus 2a. Distribute. 3 times 3 is 9. 3 times negative 2a is negative 6a. Now we have negative 2a times 3, which is negative 6a. Negative 2a times negative 2a. Negative 2 times negative 2 is a positive 4. A times a is a squared. Combining like terms, we have 9. Negative 6a minus 6a, negative 12a, plus, there's our 4a squared. And any polynomial should be written in descending order, so I'm just going to rearrange these terms. So starting with the 4a squared minus 12a plus 9.